Hello guys, welcome to our video of series called C# for Beginners. So every program we've written this entire series has had one real limitation. The moment it stops running, everything is gone. Every variable, every list, every object wiped clean the instant program closed, right? Real applications genuinely need to save data somewhere permanent, settings, logs, user data, and that's exactly what today's lesson covers. We are learning file I/O. I/O standing for input and output, reading and writing actual files on disk. Let me show the code. For example, list of string scores, right? And we have new list string, right? When the program ends here and this data is just gone, right? This list genuinely exists only while the program is running. Close it and it's gone forever. Let's fix that. Everything today is about making data survive beyond a single run of our program. So first we're gonna need the endpoint called system.io, and then maybe we have some string content equals hello, this is my first file. Some sample text we want to save, right? And then we're gonna call file dot write all text, and then here we're gonna give the notes dot maybe txt, and then content. Okay, file dot write all text and notes.txt, and then content, right? This creates a file called notes.txt, or overwrites it completely if it already exists, and it writes out the text into it all in one line, which contents is content variable. Let's run our program. As you can see, here's appeared the notes.txt, and hello, this is my first file. Okay, so let's see example writing multiple lines at once. We're gonna have string, array of string, and then lines equals line 1, line 2, line 3. Okay, file dot write all lines, and then multi-line dot txt, and then lines. Okay, and file dot write all lines takes an array of strings instead and writes each one as a separate line in the file, handling the line breaks for you automatically. So let's see the output here. As you can see, multiple.txt and line 1, line 2, and line 3. This function is automatically splits the array of strings, which is called lines or whatever variable you are calling, but it should be array of some value. Okay, and as you can see, each time we are overwriting the file if it exists, or we are creating new file and then writing it. So what about if we want to add something instead of overwriting it? To do that, we need to file dot append all text, and then here notes dot txt, and then here maybe and one more line added later. And here's the important distinction: file dot append all text, instead of replacing everything in the file, adds this to text onto end of whatever's already there. Genuinely important to know which one you actually want. Write all text wipes the file clean first. Append all text preserves what's actually already there. So let's see the output here. If you go here, it's one more line added. But as you can see, this hello, this is my first file, is not being deleted. So what I mean is here, if we don't do like that, and then if we do something like that, instead of append all text, write all text. So let's run this. And then as you can see here, one more line added later, but it's not adding the text which has already some content. It's overwriting it totally, removing everything, clearing everything, and then overwriting it. Okay, so that's why you need to differentiate it whenever you are using for kind of specific reasons or requirements. Okay, write all text and write all lines, create or completely overwrite a file, and append all text or append all lines adds onto an existing file without erasing what's already there. Choosing the right one matters. Now let's read that file back. Okay, uh, string read content equals file dot read all text, read all text, notes dot txt, notes.txt, console.writeLine, read content, read content, and then let's run this. Oops, what's going on here? Oh, I think I didn't save this. Okay, one more line added later. As you can see, files.read all text, and we are giving the location by notes.txt. This reads the entire file back in as a single string and hands it right back to user. There is a crash point on read all text. Whenever you want to read some file that does not exist, it gives kind of error. For example, something like that: string missing file dot read all text. Read all text, maybe documents.txt. Okay, clear. As you can see, we are getting the unhandled exception, system IO file not found exception. This crash, we will cover the proper way to check for that in just a couple of sections. Okay, and read all text is a mirror image of write all text, one line, whole of file in as a single string. Okay, now reading a whole file as a one giant string is fine sometimes, but often you actually want to work with it line by line, like a log file or a CSV. Remember a split from a strings lesson, right? So let me show one example. String, maybe all lines equals file dot read all lines multi-line dot txt, multi-line then file dot read all lines, and we are giving multi-line dot txt. This reads the file and immediately splits it into an array, one entry per line. No manual split needed at all this time. C# handles that for us. So let's see output for each string as in all lines console.writeLine. As you can see, line 1, line 2, and line 3. We loop through and printing each line separately. For genuinely huge files, a more memory efficient option is something like that. I'm not deleting this. I just comment it out to show you the difference. For each string line in file dot read lines read line read lines and multi-line dot txt console dot write line. line. Same output yet. And here's something worth knowing for bigger files. File.readLines without the all reads and processes the file one line at a time rather than loading the entire thing into a memory at once. For a small file, genuinely no difference, but imagine a log file that's several gigabytes. ReadAllLines would try to load the whole thing into memory immediately, while ReadLines process it gradually, line by line, with a lot friendlier or memory. Okay, ReadAllLines gives you the whole file as an array immediately. ReadLines process it gradually, worth reaching for specifically when working with genuinely large files. Okay, let's properly solve that crash risk from earlier, reading a file that might not actually exist, right? For example, we can do something like that. If file dot exists notes dot txt string content equals file dot read all text notes dot txt console dot write line content, else console dot write line that file does not exist, right? And file.exists and we are giving notes.txt returns a symbol true or false, letting us safely check before attempting to read instead of crashing and needing a try catch to recover. Okay, so let's see the output. Oops. As you can see, we are reading the file because it already exists. We can check whether the directory exists using this one bool. For example, dir exists equals directory dot exists. For example, my folder, which does not exist. Console dot write line dir exists. As you can see, it's false. There's a matching directory that exists too for checking folders rather than individual files. The following exact same pattern, okay? File.exists genuinely the first line of defense before reading or working with any file, always safer to check first than to catch a crash after the fact, okay? Now let's talk about something that seems simple but genuinely trips people up. Building file paths correctly, especially since Windows and Mac or Linux use different slash characters, right? For example, let me show you a bad example for paths, some kind of files, all folders. Bad path equals, example, it would be C, oh, C, example users, and then maybe Alex, and then maybe we can add some, and then add notes.txt. Okay. Manually gluing paths pieced together with string concatenation, worrying about slashes genuinely fragile, and it breaks the moment you run the same code on a different operating system. To fix that, we can do something like that. Notes.txt and string full path equals path dot combine folder and file name console dot write line full pass here full pass. Okay, pass.combine a folder and file name. This correctly joins pass piece together using whatever slash character is actually correct for the operating system your program is running automatically. Uh, let's see the output, and then I'm gonna show you some of very beneficial and useful pass functions for your coding experience. As you can see, my folder notes.txt, and now let me show some examples with pass and its functions. Maybe we have string file path equals maybe my folder, and then report final.pdf. Okay, first function is getting extension. Extension would be path.get extension file path dot file path, okay, file path and console dot write line extension. Okay, string file name only equals path dot get file name file path console dot write line file name only, and then string file name no extension path dot get file name without extension file path console dot write line file name not extension up, and string directory equals path dot get directory name file path console dot write line directory. Okay, so let's see the output. .pdf report final.pdf report final and my folder. Path gives us a whole set of tools for pulling apart a path. Get extension for just the file type, and get file name for the name including extension. Get file name without extension, and get directory name just for the folder portion. Okay, genuinely handy anytime you are processing file names dynamically rather than hard coding them. Always use path.combine and other path methods instead of manually gluing strings together. Genuinely avoids the whole category of subtle platform-specific bugs. Okay, so far we've been saving plain text, but what about saving actual objects? Remember our classes from a few lessons back? Saving structured data as a plain text gets messy fast. This is where JSON comes in, a really common structured text format for representing data, and C# has a great built-in support for converting objects into it. And let's create our object. First, maybe we have class, student, public, string, name, get, set, and empty string. Okay, public, int age, get, set. Okay, and then student equals new student, maybe name equal Alex, and age is 20. Okay, the familiar student class and one instance, right? And then string JSON equals JSON serializer dot serialize student console.writeLine JSON. Okay, JSON serializer dot serialize, and we are giving students object. This converts our entire object into a JSON format string automatically based on its properties. This prints something like curly brace name Alex age 20 closing curly brace. Okay, so let me show you output. As you can see, name Alex and age is 20 inside the curly braces, right like the JSON format. And now, combining today's earlier topics, we just want to write a JSON string out actual files using write all text exactly like before. Let's do that. File dot write all text, right? And then maybe student dot JSON, and then our JSON. Let's run this. And as you can see here, there's a student JSON, and we are saving our object properly as a JSON format. And how can we make it more human readable? As you can see, as our object gets bigger, it gets bigger in one line, and it would be kind of hard to read that. So to make it much more human readable, there's already built-in options attribute in JSON serializer. So we're gonna create here option var option equals new JSON serializer options dot not dot write write intended true. Okay, and then this one, yeah, oh, comes here, and then here we give options our option. Okay, and then console.writeLine this one. Okay, as you can see, it's much more good. Yes, and if you wanted the JSON nicely formatted spread across multiple lines instead of all one, remember object initializer syntax from a class lesson. We pass in a JSON serializer options with a write intended set to true. JSON serializer.serialize turns any object into a structured readable JSON string ready to save it to a file, genuinely the standard way to persist structured data in modern applications. And naturally, we need the reverse, reading that JSON back and turning it to a real usable object again, right? To do that, we're gonna do string, save it. Let me close the terminal. Okay. Save it. JSON equals file dot read all text and student dot JSON. Reading our saved JSON file back in as a plain string using read all text from earlier. Okay, and then student nullable loaded student equals JSON serializer dot deserialize type student and save it JSON. Okay, student question mark and load student equals JSON serializer dot deserialize and student object in the student tab and save it JSON, right? Remember generics from a few lessons back. Deserialize is a generic method. We tell it exactly what type to convert the JSON back into student in this case, and it hands us back a real usable object. And here, if loaded student is not null, console.writeLine loaded student dot name is loaded student age years old. Okay. and now it's nullable. Remember, nullable reference types from a couple lessons back. Deserialize could genuinely fail and return null if the JSON is malformed, so we check before using it. Okay, so let me show the output here. As you can see, Alex is 20 years old. We are saving JSON first and then reading back and deserializing to our object, and then we are showing the output to user or whoever you want. Okay, and bringing all of the things together that we've covered today. So maybe we're gonna have a student uh, student class, and then let's see, we have a list of students, not just one student. Maybe list students, maybe students equals new list student, and then new student name equal Alex, age equals 20, new student name Sam, age equals 22 maybe, and then we're gonna say string students dot JSON equals JSON serializer dot serialize students. Okay, file dot write all text, write all text students dot JSON, and then students JSON, and then we load from file string loaded JSON equals file dot read all text from students.json. Oh, let me copy it in here. File name student.json, and then we're gonna try converted list of students, and it with nullable loaded students equals JSON serializer of JSON serialize dot deserialize, and then type would be list of students of deserialize list of students, and then here loaded JSON. Okay, and then we're gonna show output sort var as in loaded students loaded students new list student console console.writeLine here s.name and then maybe age. Okay, and genuinely this works for entire collections too, not just a single object. A whole list of students, serialize it, save it and read back, and then deserialize write back into a working list. And notice that full coalescing operator at the end from the nullable types lesson, falling back to an empty list just in case load genuinely failed. Okay, so let's see the output. Okay, as you can see, we are first giving the to file giving some information from, we can get this information from the user, and then saved and then serialized to JSON, and after serializing we are considering it as string and then saving to file, and then getting from that file and deserializing and converting to object, and then we can show to user exactly same information. Okay, so serialize converts an object into JSON text. Deserialize converts JSON text back into a real usable object. Together, this is genuinely how most modern applications save and load structured data. Alright, let's close this out with a realistic mini application, a simple note saving system maybe. Okay, so let me close the terminal first, and then let's just delete all of things. So first, maybe we're gonna have a class called note, and then public string title get set, and then public string content get set, and then public date time created at get set equal date time dot now. Okay, and then here string maybe notes pass. I'm gonna give pass up pass dot combine data and notes.json. Let me create here data folder. Okay, and then list of our notes equal new list note, and then if file dot exists notes path string existing JSON equals file dot read all text notes path notes path. Okay, and then notes equals JSON serializer dot deserialize, then type would be list of notes, and then existing JSON. Okay, existing JSON or new list note. Okay, new list note, and notice dot add new note title equal maybe a reminder, and then content equals finish maybe C# series. Okay, and then we have string updated JSON. We serialize it, JSON serializer, serialize, and then notes, notice, and then new JSON serialized options, JSON serialized options, write intended equals true. Okay, and then for each var note in notes console.writeLine note.title, and then note.content, and then maybe time also, note.created at. Okay, done. Here, as you can see, we have a node class and also path built safely with path.combine, and we are checking whether a saved file already exists and loading existing nodes. If it does, and adding new nodes, saving everything back with a nicely indented JSON, and printing the whole updated list using a date format specifier from a couple lessons back, right? So let's see the output. As you can see, a reminder, finish C# series, and the date is 17th of August 2026, and the time is 1:26 p.m. Okay, and we use it here: file existence checks, path manipulation, JSON serialization, and deserialization, all working together. Okay, this is a genuinely a real working save and load system, the same basic pattern countless real applications use. Okay, so for today's lesson, your challenge would be building a simple task class with title and is complete. Write a small program that loads a list of tasks from a JSON file if it exists, adds a new task and saves it back. Run your program a few times and confirm the task genuinely persists between runs. Okay, so today we covered writing and reading text files, working with the lines efficiently, checking whether the file exists before touching a proper manipulating files, and finish it with JSON serialization and deserialization for saving and loading real objects. File I/O is genuinely how programs remember things beyond a single run. Settings, user data, logs, all of it relies on what we covered today. Next time we are covering HTTP requests, how to make our programs talk to the internet. See you there. Take care.